In this video, we're going to talk about statistics in psychology. So in statistics, we have something called measures of central tendency. So we mainly talk about three of them, so mode, median, and mean. So what do these mean specifically? Mode is the number that appears most often in a data set. And median is the midpoint number, or the number where half of all the data is above it, half of all the data is below it. And then the mean is going to be the arithmetic average, which is all the numbers added up divided by how many numbers you have. Now, a quick chart to show kind of what this looks like. As you can see, the mode here is the most common data set. The median is kind of in the middle, and then the mean is kind of pulled toward outliers. Now we have different types of distributions. So we have a normal distribution, also known as a symmetric distribution, where the mean, mode, and median is the same, and you have a nice bell curve. We can also have a negatively skewed distribution where the mode is higher than the median, and then the median is higher than the mean. When you have a negatively skewed data set, there's going to be an outlier that is very low. So that's why it's called negatively skewed. When an outlier is very high, you're going to have a positively skewed data set where the mode is lower than the median, which is lower than the mean. So now let's talk about measures of variation. We talked about measures of central tendency. Measures of variation, let's just give an example. So let's say Benzema scores 1 goal in every game he plays. Asensio doesn't score in 2 games and then scores 3 the next game. So which player is more reliable? Well, obviously Benzema is more reliable. Even though they scored the same number of goals per game, they would score 3 goals in 3 matches. Benzema was more reliable because his goals were spread out over 3 games as opposed to Asensio, whose goals were just in 1 game. So we have some measures of variation so we have one called range, which is basically the gap between the lowest and highest score. And then we have standard deviation, and standard deviation measures how much each individual score differs from the mean. So what this means is that if standard deviation is higher, that means that the data or the scores are more spread out. And so if you look at the left, a low standard deviation would look like this, and a higher standard deviation would look like this. The data is more spread out than it is here. So when we look at a normal distribution, normally it looks like this. About 68% of the data is going to be within 1 standard deviation, like this. And then 95% of the data is going to be within 2 standard deviations. And about 99.7% of the data is going to be within 3 standards of deviation. And we can actually match up scores with this. These numbers are the Wechsler IQ test. So that means that 68% of the population has an IQ between 115 and 85, and then 95% would have an IQ between 130 and 70, and so on. And you can see that the outliers are very rare. Now we have a slight problem in statistics, and that is that data happens to be inherently noisy. What does this mean? So if you look at study 1, we get something like this. In study 2, we get something like this. The data sets aren't exactly the same, and the pattern isn't perfectly reflected in the data. There's some noise, right? There are going to be outliers. It's not going to perfectly fit into this line. there's a little bit of variation here and there. So that's called noise. And the reason this could happen is because one experimental group in a study could differ from another one, not because of any real difference, but because of just chance fluctuations in the people sampled. So when is observed difference reliable? Or in other words, how do we tell that the pattern we're seeing is real and is not just due to noise or chance? So there are a few indicators we can use to tell if our data is reliable. One is that a representative sample is always better than a biased sample. And less variable data is always more reliable than more variable data. Large variability can be due to noise. And if we have more cases than we have less cases, then that's going to be better. So, for example, how many studied see the trend, and how many people were in each study? Right? A sample of 5 is not going to be as good as a sample of 500. The other question we have to ask is, when is the difference significant? So there's a term called statistical significance, which basically measures how likely it is that the result occurred by chance. Now, in psychology, in order for the results of a study to be considered statistically significant, the probability that the results were just created by chance has to be less than 5%. That's the important number. So if there is at least a 95% probability that the results didn't come about as a result of chance, then the study is statistically significant, or the results are technically statistically significant. One thing I didn't mention, which I forgot to, I'll correct myself here. Standard deviation would be the difference you see in each little space. So in this case, for the IQ, the standard deviation is 15. If it was higher, if it was, let's say, 30, then it would have a higher standard deviation.